Welcome to the second screencast lesson by Miss Gooch. Today is October 4th, 2017, and we're going to talk about vector components now. So recall yesterday we introduced the topic of two vectors being added together to create a resultant vector. So there's vector A plus vector B equals vector R, and vector R we found by determining the magnitude of the hypotenuse, just like Pythagorean theorem, using Pythagorean theorem, and then the angle was the inverse tan ratio of the two sides. So that's how we found the magnitude and the direction of vector R. Today what we're going to do is go backwards, and we're going to be basically given vector R, can we break vector R up into A plus B? So that's called breaking it up into the horizontal and vertical components. The reason we do this is because when we get to forces, momentum, we have two-dimensional vectors, and we have to break them into components in order to find their overall net effect on something. So this is a basic concept that you will be carrying on in throughout physics from here on out. Okay, so let's do a couple of examples to see what it is I mean by breaking a vector up into its components. So here's example 1. It says break R vector up into its horizontal x and vertical y components. So here you're given a vector R, and it's 40 meters east, 30 degrees north. So what we are going to do is we're going to create a triangle with vector R as the hypotenuse. Our x is going to be the x component, and it's going to be pointing eastward because part of this vector is east and part of it is north. The vertical component will be called RY, and then our angle we put in there is 30 degrees. So that makes us a little right angle triangle, and we're going to be able to use trig to determine our x and y components. So let's put in our value for R. That's 40. Okay, I'm not going to worry about units at this point. I just want you to figure out the math first. So what I'm going to do is, because I've got the hypotenuse here and the opposite side and the adjacent side required, I'm going to be doing a cosine ratio and a sine ratio to find my missing components. So cosine of 30 is going to be Rx over 40, and sine of 30 is going to be Ry over 40. So when you rearrange that, Rx is going to be 40 cos 30, and Ry is going to be 40 sine 30. Once you plug that into your calculator, you get 20 meters for Ry and about 35 meters for Rx. I'm just rounding to the nearest whole number because my original values were given to the nearest whole number. So that means my x component of my R vector is 35 meters in the direction of east, and my y component R vector is 20 meters in the north direction. And that makes sense because originally we had r here that was north and east directions, which works out because my horizontal and vertical components should have north and east associated with them. Okay, so that's basically how we break one vector up into its two components, the horizontal and vertical components. So what do we do with that? Now we have to go a little farther. Okay. So you may come up to a question that says something like this. Example 2, find the overall displacement if I travel 305 kilometers north 45 degrees east and then 200 kilometers south. So what we're going to do is we're going to draw those two vectors, adding them together, because what are we doing? We're walking two different directions, and the total displacement will be measured from adding the two vectors. So we're going to go north 45 degrees, oh gosh, that should be straight, it's curvy though for some reason. That way, 305 kilometers, and then I go 200 kilometers south. Okay, so then my resultant vector is something like this. Alright, so in order to find r, or my result, what I'm going to do is I'm going to break this guy up into components and combine the horizontal components of each vector and the vertical components of each vector, and then figure out an overall displacement vector. So let's see what that looks like. So the way I like to organize this is to outline, I'm working with two vectors, and in each case they have an x and a y component, or horizontal and vertical component associated with them. So my first vector is like this, so it's 305, and then some angle 45 degrees. So I need my, let's just call this A. Hang on, move that out of the way. A. So we're going to do AX plus AY. Gives you vector A overall. So AX, because that's the adjacent side, we're going to do cosine. Sorry, my stylus is being a pain. Cosine of 45 equals AX over 305. AX equals 305 cosine 45. So I'm just looking for the value of the horizontal component of this vector. And that's 215.7 kilometers. So I'm just going to move some things over because it's getting in the way. Move this stuff over. I have the luxury of being able to do that, and you probably don't. I apologize. The y component is going to be similar, except I'm going to use sine 45, and if you know anything about the angle 45 degrees, you're going to know that I'm going to get the same answer for the y value. Okay, so the x and y components of the first vector are the following: 215.7 kilometers, and that was in the east direction, and then AY is the same number, same units in the north direction. So now we can move on to vector 2. Vector 2, so if you notice here, vector 2 is only going in the south direction. So that means I don't have any x component. So that's less work for us, which is nice. Let's call this vector b. So the y component of vector b is just 200 kilometers south. And we don't have to break anything up into components this time because it's already in components. Okay, so what do you do now? So if I redraw the situation from before, I had vector A going off into this direction here, plus vector B gives me vector R. Okay. Vector R isn't perfectly straight or horizontal. We don't know what direction it's going. That is the be-all and end-all reason we're doing this question. So we know that I could break up A into components and B was already in components. So R is going to be, let's just kind of exaggerate this. The vector R is also made up of components. Okay? And this is where the reason being we broke those originals up into components comes into play. Basically, Rx is a sum of the x components of the original vectors. Ry is the sum of the y components of the original vectors. And then R is found, you know, the same way we did before. It's going to be the value of x squared plus the value of y squared. And then the angle is going to be the inverse of Ry over Rx. I know that looks like a lot now, but once you get used to the sort of methodology, this sort of becomes step-by-step process. So right now let's just find Rx by adding what was Ax and Bx. So the x component of A was 215.7 east. So 215.7 east. And the x component of B, there was nothing, so you don't have to write anything there. So that's done. The y component of R is going to be the y component of A, which was 215.7 north, plus 200 kilometers south. So we gotta figure out which way we want to go, positive or negative. So we'll say north is positive, because in this case it's bigger. So my y component of my r vector is just going to be 15.7 newtons north. So you don't have to draw and redraw R every single time, but I'm just showing you again what this looks like. So this is 215.7 because we just determined that horizontal component, and then this is just 15.7. So now I can figure out my magnitude of R as well as the angle at which R is going. So let's find the magnitude of R by applying the Pythagorean theorem. And by the magic of television, I got an answer of 216.3 newtons. The angle is the inverse of 15.7 over 215.7, which is 4.2 degrees. Very small. And if you look back over here, you see here, the angle at which little r is coming off of that east side is really, really small. So 4.2 degrees makes sense. Okay? So our final answer, I know it seems like forever ago that we started this question. Our final displacement is 200, so we'll do 2.2 times 10 to the 2 kilometers north, 4.2 degrees east. Whew. So in summary, all two-dimensional vectors can be broken up into their x and y, or vertical and horizontal components. In addition to, when we're looking for the resultant vector, that can be determined by breaking each vector into its components, adding them together, the horizontal with the horizontal, the vertical with the vertical, and then bringing those two directions together and creating a right triangle for the overall resultant vector r, which we learned how to solve yesterday using SOHCAHTOA and Pythagorean theorem. So I hope you're not overly confused. If you need to watch the video again, it was about 17 minutes. You'll have time to do so. And I will be we'll do a summary take-up of this on Tuesday, I guess, will be the next time I see you, if not tomorrow, when you check in for Pink Day. Alrighty, have a great day, and all the best. Bye. Oh, I should add, please complete the homework outlined on the Google Classroom. It's just 3 questions out of the textbook. And check your answers. Okay, I'll post solutions to those tonight. Alright, bye-bye.